questions at this point? Nothing? Any questions about anything? All right, well, let's plow forward. As I said, I had a assignment for you. Let's see, yes, please.
Last time we had talked about the operator, the brackets operator, we were not implementing the GPL.
Right, maybe I misarticulated it. So my intention was to say that in C and C++, the subscript is an operator in the same sense that the plus sign is an addition operator. In GPL, there's certainly subscripts. I mean, you've already been running tests that are dealing with arrays, but it is not implemented as an operator. You'll only find that as part of a rule that basically combines that variable with the operation into a, what do I want to say, an atomic unit. So they can't, in other words, you can't, in C and C++, I can use an ID, if I declare an array called ABC, I can use ABC naked throughout the program, depending on my need, if I need a pointer or something like that. That you can't do that in GPL, so that's the distinction.
And it was really just to sort of demonstrate the distinction.
Wanted to make note of the distinction, but I think that the value that I perceive in offering up what we did with the subscript last time was to really drive home that it isn't something magical that's happening in C and C++. It's just giving us a visually convenient way of doing something that I think that we're comfortable with semantically, which is taking an address, adding an offset to it, and dereferencing it. Yeah. Other questions? All right. I like questions. Oh, let's see. So if we go to assignments, this third one down, associativity and precedence. That won't be due today, although I wanted to kind of kick it off today and work on it in class. That'll be due, today's the 26th, so like before class on Tuesday. So you have the weekend if you need it. You can conceivably finish it in class. All right. The assignment write-up is separate. So you click on that. That'll bring up another page. There are a couple files to download. So right-click or control-click on a Mac and save link as to your favorite location in the Linux world. And it is a fully functional, if simple, grammar. As far as the regular expressions that we can match digits, which become the semantic value of our good friend t-int constant. That's where the similarity ends. There is a subtraction, t-minus token that can be matched, and then errors for anything else, and of course skipping white space. So not a lot there. If we look at the grammar, there are 3 tokens that we have. We have some boilerplate stuff that we have in there. And all we can do is subtraction. So an integer constant can reduce to an expression, and then once we have an expression, we can marry together 2 expressions with the minus sign. So there should be nothing at all alien about that. I run flex. Bison, and then G++, standard equals C++ 17. That's going to generate lex.yy.c. That's going to generate, I think, simple tab.c. Am I missing anything? Nope. All right, then I can say echo 7 minus 3 minus 3. I guess I should use the numbers I use here. 953. 953. I can pipe that into, oh, that's what's different from the write-up. And rather than a.out, that was written to a program called calcit. Again, this is all in the write-up. The only difference is in the write-up I have them as 3 separate commands, and what I did just now is I combined them with the shell's Boolean AND operator. So I take that, I pipe it into calcit, and 9 minus 5 is 4, minus 3 is 1. So the first part of the series of steps that it's asking you to do is you go into the Bison file and you remove %left. So we have a fair number of these directives to Bison and GPL to help us deal with precedence. We want to go ahead and get some experience changing our grammar to build in precedence rather than relying on Bison's directives to do so. So I remove that, and if I go ahead and go through the same drill, having removed the Bison's precedence directive, then we get a shift-reduce conflict. And that shift-reduce conflict is born from, there's my grammar. If I have 9 minus 5 minus 3, was it? The 9 is our t-int constant. That reduces to expression, so this becomes expression. And then we're potentially going to match expression t minus. I get another constant. That reduces to expression. I get this. And it is at this point, so there's a series of shifts and reduces that gets me to this point here where I have this on the stack. And what I have on the parsing stack will certainly reduce according to the rule on line 26. However, the parser does have the ability to look ahead one token, and it sees the next thing that it can shift is a minus, and it can potentially match this expression minus that, and then so under the hopes of ultimately matching this. So that's the shift reduce conflict. Either you can reduce here or you can shift here with equal validity. And so we want to change our grammar, enhance our grammar, such that we get left associativity. And I know that semesters are long and memories are short, so I would direct you back to the home page of 515. And if you go to, let's see here. So it looks like around the Tuesday, Thursday of week 4, this says integrating associativity into grammar. So you might be able to pull it out of the hat by just looking at some of the files that were posted. In the worst case, put on headphones and watch the screencast, or skim it, whatever. Or you got people sitting next to you, right? Go ahead and knock heads with someone near you to see if you can jog your memory as to how you're going to enhance that grammar to get associativity. So that's the start of it. That's just the first step. And then you can go ahead and test it. You should be able to build it without any shift-reduce conflict, so you know you're on the right track if you no longer get that warning. So that's step 1. Step 2 is you're going to be asked to add another operator and introduce precedence. So you'll add division Division should occur before subtraction. Again, all these should be modifications to the grammar, the big banner at the front here. Don't use it. If you have these anywhere in your grammar, then you're doing it wrong. Or anywhere in the Bison file, I should say. So introduce precedence. You add addition and multiplication. This is probably the fairly easy step once you get subtraction and division working. And then this one is a little bit trickier. You have to add exponentiation. So being able to say 2 raised to the 3rd power is 8. Rather than using, so there is in the library, there is a POW function. Rather than doing that, just create a loop and multiply this thing 3 times. Okay, one of the problems with that function is that it returns a double, and we're trying to work strictly with integers. So it's very simple just to create a loop to create the answer to that. And then the last step is to ensure that exponentiation is right associative, not left associative. And so when you have an expression like this, the associativity matters. And there's a little test for that there. I'll let you work a while, and then I'll bring it back up here, and we'll work through the first step, maybe the first couple of steps together. And yeah, so that's what I have planned. So go forth and be productive. Interrupt your thoughts for a moment. Someone want to walk me through introducing associativity here for subtraction? Okay. What do you want to call that variable? NBR? Like that?
Yeah. And then you change the expression t minus expression to be the expression t minus NBR. I don't know if it matters, but I put the expression t minus NBR above.
Yeah, the order of these two, if they're all ORed together, the order can be anyway. So that works, I'm sure. It was 5, it was 9 minus 5. 9 minus 5, there we go. Very good. And then our second one, introducing precedence. So we have to add division. So we can call that token, doesn't matter, we'll call it divide. Named after the great Anthony Divide, who invented division back in 300 BC. And let's see, we need to go to simplearithmetic.l. Do one of those, do one of those. All right, so help me enhance this to get division into the mix. You want to go again? Do you have division in? I'll give you an extra gold star. What do you want to call it? Div? And that's going to be NBR? Div t divide NBR. And then this has NBR here? And then this becomes div.
Take out the end bar. Oh, no, you do that.
Just like that? I think so. And let's see, this was our test. Nope, this was our test. Oh, let me see, what did I do wrong? Oh, I know. A lot of copying and pasting and not enough computing. So what do we want to do here? We want to say that $$ is equal to $1 divided by $3. And then this would just be basically an echo of that there. $$ equals $1. Oh, now we can try that. And there we go. Yes?
Can you try to just 10 divided by something? I have an issue where I was using multiple different expressions and I can't do just 10 divided by 5. I'll need some guys do that.
So what has to happen there in that case is you need to make sure you have this rule right here. I don't know if you have that. So you get the first two numbers floating up here. The first number becomes div. The second number floats up, assuming you have the division. So then it's going to match this rule, and that whole thing, it becomes div. Then there's no more work to do. So that div floats here to expression. Again, there's no more work to do, so that expression floats to the start symbol. All right, I will let you finish up.